An international team of researchers has successfully used NASA's James Webb Space Telescope to map the weather on the hot gas giant exoplanet WASP-43b. It's a gaseous exoplanet the size of Jupiter but with double the mass. This alien world is located about 260 light-years away in the constellation of Sextans. WASP-43b is a hot Jupiter type of exoplanet, similar in size to Jupiter, made primarily of hydrogen and helium, and much hotter than any of the giant planets in our own solar system. Although its star is smaller and cooler than the Sun, WASP-43b orbits at a distance of just 1.3 million miles, less than 1/25th the distance between Mercury and the Sun. WASP-43b lies so close to its host star, the orange dwarf star WASP-43, that it completes an orbit in just 19.5 hours. Sometimes not finding something is just as exciting and useful as finding it. Take hot Jupiter WASP-43b, for example. This tidally locked world has a searing hot, permanent dayside and a somewhat cooler nightside. Astronomers using Webb to map the temperature and analyze the atmosphere around the planet expected to detect methane, a common carbon molecule, on the night side. But there is clearly no sign of it. Why? The result suggests that supersonic winds of hot gas are blowing around from the dayside, thoroughly churning up the atmosphere and preventing the chemical reactions that would otherwise produce methane on the night side. Precise brightness measurements over a broad spectrum of mid-infrared light, combined with 3D climate models and previous observations from other telescopes, suggest the presence of thick, high clouds covering the night side, clear skies on the dayside, and equatorial winds upwards of 5,000 miles per hour mixing atmospheric gases around the planet. The investigation is just the latest demonstration of the exoplanet science now possible with Webb's extraordinary ability to measure temperature variations and detect atmospheric gases trillions of miles away. The measurements show that the dayside has an average temperature of nearly 2,300 degrees Fahrenheit, hot enough to forge iron. Meanwhile, the night side is significantly cooler at 1,100 degrees Fahrenheit. The data also helps locate the hottest spot on the planet, which is shifted slightly eastward from the point that receives the most stellar radiation, where the star is highest in the planet's sky. This shift occurs because of supersonic winds, which move heated air eastward. WASP-43b is cloudy on the night side and clear on the dayside, with equatorial winds howling around the planet at 8,050 kilometers per hour. The results were published in the journal Nature Astronomy.